Is my screen visible now? Can you acknowledge? Is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So in today's class, we will go through the next concepts, that is classification of the data structures. So data structures broadly we can categorize into two things. The first one is the primitive data structure and second is non-primitive data structure. We will study what we mean by primitive and what we mean by non-primitive in the upcoming slides. So here we'll just go through its classification, okay, and then later we will discuss each one of them. Okay. In primitive, we can have a sub-classification or an example. So we have a int. Can you guess what could be the next one? Char, float, double, right? Yeah, and we have one more entry in the data structure under the primitive, that is pointer. Okay, so in primitive we can have 5 different types: integer, character, a floating point. Then in floating point number we can have 2 sub-classification, that is a float and a double, and then a pointer. Okay, and coming on to the other side, that is non-primitive. In non-primitive we can have 3 sub-classifications: arrays, lists, and files. Out of these 3, I hope you have already studied arrays, right? Can you tell me the classifications what we can have for arrays?
One-dimensional, two-dimensional, and multi-dimensional.
Very good. We can have a one-dimensional, that is a single dimension we can call, two-dimensional, and multi-dimension. Okay, then under the list we can have 2 sub-classifications again. One we call it to be a linear lists and second is non-linear list. Again, we will discuss what the concept behind this linear and non-linear and with the examples. Okay, and then inside again linear we can have a data structures, or the types of that could be a stack, queue, and linked list. Okay, under linear we can have 3 examples or 3 different data structures: stack, queue, and linked list. And under the non-linear we can have a trees and graphs. So this is the classification of a data structure what we can have. Okay, now pay attention here. So in your syllabus, okay, in your syllabus what we are going to study in detail is that, now if you think here, some of the concepts are already covered in C programming, like int, char, float, double, as the data types it is been already covered. And we have also studied something called as an arrays, right? One-dimensional arrays, two-dimensional arrays, multi-dimensional arrays we have studied in a C programming language. Apart from that, did we study anything else in C programming? No, right? We didn't study
No, sir.
anything apart from that. Okay, so in data structures, what we're going to study is that as per unit-wise distribution, if I do, in the unit number 1, we are going to cover up the pointers. We are going to cover up pointers along with the files. Okay, so your unit number 1 constitutes the pointers and the files. Okay, and then in the unit number 2, what we have is that the concepts related to the arrays, which we have already studied, but here the further additional concepts will be certain operations which we can perform on the arrays, like the searching and sorting techniques. Okay, suppose if there is an array and we want to search a particular element, whether it is present or not, right? There are different types of techniques available. Those techniques or the methods we are going to learn in the second unit part, that is under for the arrays. At the same time, we are also going to look for certain concepts related to the sorting operation, right? Sorting means kind of arranging the elements in the given array. There are varieties of concepts or the methods or techniques available. Those we are going to look for, right? And then from the unit number 3, we are going to look upon certain concept of a recursion, okay, and then followed by a type of a data structure called as a stack, right? What we mean by a stack and everything, we are going to look upon the stack in detail. Then unit number 4, we focus upon queues, and unit number 5 we focus on the linked list. So from this particular classification, it will give you a hint that what this particular data structure subject consists of and how we are going to study them. Okay, yes. Let's quickly jump onto the concepts behind that. So primitive data structure means what? These are the data structures which are directly operated upon the machine level itself. So machine level instructions means what? As a programmer, as a user, need not to worry about how we declare them or how operations are performed on them. That task will be directly taken care by the computer itself, right? So that's what we mean by machine level instructions, right? Machine level instructions, the example we had given there, right? The examples were the integer, character, float, double, and pointer. If you look at all these pointers, you can, as of now, you can just exclude it. The remaining 4 here, integer, character, float, and double, if you look upon, they are used to represent what? Only a single value. Single value means what? Suppose if I write int a equal to 10. So a can, at the max, it can have only one value to it. I can't store a equal to 10 comma 20. It is not possible. So the primitive data structures can have only one value to it, right? We can't have a multiple values, right? And at the same time, these representations, right? All these primitive data structures representation, it varies depending upon the architecture of the particular computer. It varies, the representation varies. What we mean by that is that the amount of space required to store that particular value in that data structure, it differs than one computer to the another computer. For example, it could be that on a particular computer, integer data structure may take, say, 2 bytes, but on the other computer, it may take 4 bytes. And even on another third machine, a third computer, it may take 8 bytes also. So the representation will differ based upon what type of the architecture it is. So if you want to summarize, the primitive data structures are what? You can think that these are the simple or primitive data types, right, which you have studied. But along with that, we do have a pointer here, right, so that we can call it to be a data structure. And all these primitive data structures are operated directly by the machine level instructions, and all they can store a single value only. We can't store a group of values or a multiple values, and the representation varies depending upon the computer architecture. Okay, is this followed, students? Any doubts? At any time, students, if you think that some concepts are not clear, then and there itself, unmute yourself and ask questions. Okay, yes. Moving further, the second, that is a non-primitive. If you look upon here, the problem with the primitive data type or primitive data structure is what? They can store only a single value, isn't it? Now, if a programmer or a user wants to store multiple values for a particular data structure, then it cannot be made possible in what? Primitive type of. Then we need to solve this particular problem, or programmer need to overcome this particular problem, right? So to do that one, there is a type of a data structures which we call them to be a non-primitive data structures. These non-primitive data structures are derived from primitive data structures. Meaning is that making use of these primitive data structures, the programmer or a user can create their own data structures, right? So that we can term it as a derived from the primitive data structures, wherein the programmer can solve the drawback of the primitive, which we discussed as the single value, right? So in the non-primitive, these type of data structures can store the group of values. It can store a group of values. Okay. Examples: arrays, lists, and files. Okay, as you know here, right, in arrays we have studied. What is the definition of array, students? Can anyone tell me definition of array?
Set of homogeneous elements.
A set of homogeneous elements. Okay, what else? Okay, let's go in this way. Let us discuss upon arrays. You have studied in the first semester, right? So let us important concepts of an array. Can you list it? Probably one by one. Anyone? Okay, one of you said that list of elements. homogeneous elements, to be more precise. Okay, what else?
List of related data items that share a common name.
Very good. A list of related data items, that is a homogeneous elements, and all those homogeneous elements shares a common name. Very good. That is the first point, a collection of homogeneous elements stored under the same name. For what type of data type we can create arrays? We can create arrays for integers, we can create array for
data.
characters, floating point numbers, right? We can create the arrays. Do you know what do we character array is called as what? Character array is called as
Strings.
strings. Very good. The character array is called as strings, right? Then, do you know that arrays, when we declare in a program, that is in the C program, they are stored or they occupy consecutive memory locations? The elements of the arrays, they occupy the consecutive memory locations. Are you aware about this? Did you study what actually we mean
Yes,
by
sir.
consecutive memory locations? No, I'm just asking a feedback. If you are not aware, then I will explain that concept. Have you guys studied or no?
No, sir.
Okay. If no, let me give a quick try here. Okay, 1 second. Let me open up an Excel sheet and then I can try to show you pictorially what we mean by the memory locations. Pay attention. This particular concept is going to be helpful, useful for the next upcoming class concepts related to the pointers and all. Okay, pay attention. Okay, now, so computer memory means what? It will be having a space to store the data. At an granular level, in the computer memory, we can have something called as an blocks. We can something called as an blocks. And each these blocks can store exactly 1 byte of data. It can store exactly 1 byte of data. When I say blocks in the computer memory, that means what? It is the smallest unit of a computer memory and which is capable of storing exactly 1 byte of data. Okay, now try to visualize it. Okay, let me say I'm just taking a small portion of the computer memory and I'm putting certain blocks here. 1 second, students. Just a moment. Yes. Okay. Students, are you able to see this text? Is it too small for you to look or should I increase the font here? Is it visible now better?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Students, since I'm engaging the classes for you this semester only, I need acknowledgement for my questions. Okay. If I ask something, do try to acknowledge. Okay. Now, so what I'm doing here is that I'm just taking a piece of a memory block, a computer memory, okay, wherein I can say there are some blocks here. So block means what here? Okay, suppose if this is one block, so this block can store exactly 1 byte of data. Then there is another block, and this block also can store exactly 1 byte of data. Okay, I hope this is clear now. Next is that now there should be something, a kind of a mechanism wherein these blocks should be identified or should be traced upon. If I want to give an analogy, now think that post uh, uh, someone say one of your friend has posted some kind of a cards, the postal cards to you. Then how that particular postman will understand that that particular postcard belongs to you only? Based upon the house address. Yes or no? Based upon the
Yes,
house
sir.
address. Yes or no?
Yes, sir. Yes.
Right? That means what? Every house have or can be identified by an unique identification. We can call it to be a postal address or the address of that particular house. We can't have two houses to have a same address, isn't it? In the same way, in the computer memory, every block, each one of these blocks have their own addresses. They have their own addresses. Okay, generally these addresses are an hexadecimal numbers. Okay, I hope you remember, what is a hexadecimal numbers, right? A number constituting 0 to 9 digits and an alphabet A to F. It's just a combination of an hexadecimal number. For a simplicity, what I will show you is that I will write a 4-digit number here. Say 1001 I will write. That means what? 1001 is what? It is the address of this particular memory block. This particular memory block. Okay, then after this one, say there is a next memory block, the next consequent memory block here. Then address of this memory block will be 1002. Okay, now after this memory block, then we do have a third. Now, can you tell me what will be the address of this memory block?
1003.
1003. Then the next one would be what? 1000.
1000.
In this way, we will be having the addresses of every block of a computer memory. And each and every block of this computer memory will be traced or identified or recognized by these addresses only, right? Usually the address will consist of a hexadecimal number, but here for the simplicity, I'm just using a simple numbers for better understanding. Okay, now look back onto the, let us look back into the some conventions which we had written in the C programming. Say in the C programming, while if you want to declare a variable, say int a, right? You write an declaration statement int a and semicolon, right? Isn't it a declaration statement wherein you are declaring a variable by the name a of integer data type? Yes or no?
Yes, sir.
Right? Now,
Yes.
let us understand, when we write a statement, when we write a declaration statement like this, what exactly happens in the computer memory, right? Pay attention here. Now, it says that compiler says that, okay, programmer has declared a variable and he has used an identifier, the name given to it an a, and this a is of an integer data type. Then it asks the computer, okay, you are a this so and so architecture computer and you need 2 bytes of memory to store this particular variable a. Okay, 2 bytes of memory it requires, it says, but the computer memory, every block is what? Can store exactly 1 byte of data only. It can store only 1 byte of data. Then what the computer or the compiler will do? What it will do is that 2 consequent memory blocks, that is these 2, now will be allocated for the variable a. That means, now suppose if there is a variable, this a belongs to what? It belongs to these 2 memory blocks. It belongs to these 2 memory blocks. So this together is what? It is a. It is together, it is a. Understood? Let me try to put it properly so that you can better understand here. Okay, now a means what? 1001 memory block, 1002 memory block. These 2 memory blocks are allocated for the variable a. Suppose next time if you perform some operation like a equals to 10, then what is going to happen? Okay, computer will say that okay, the identifier a which is been declared or which is been allocated the memory block, in that particular memory block you go and store the value 10. That means the 10 will be allocated in these two memory blocks, let me try to show you like this. So 10 is occupied not in a single memory block but two consequent memory blocks. Is this understood, students? Now
Yes, sir.
Yes, sir.
okay, now here together these two blocks it will make to be a 2 bytes of data. So this 2 bytes of data is for what? It is for the variable a. It is for the variable a. Right? Now assume that a programmer will write one more statement here. Like say here he could have written a and then b. He has declared two variables, int a comma b. Now tell me what may happen. Two variables are declared. So what is the implication of this on the computer memory? It is that two variables are there, a and b, of the data type integer, right? Each of these variable require 2 bytes of memory, right? Then what computer can do? Okay, computer try to identify two consecutive memory blocks. For a it has allocated some 2 bytes, and for b let me pull out some lines here so that I can fill in the values. Okay, now say I need a b also. It will try to find out a bb, some two memory blocks. It may allocate these two memory blocks, or it may allocate these two memory blocks, or sometime it may allocate these two memory blocks also. It doesn't matter for the compiler. It can allocate any two consequent free memory blocks. Okay, assume that it is going to occupy these two memory blocks. Okay, and then it will allocate there, say these two memory blocks. Let me put out a border for that for your understanding. So this is what? This is going to be a b. So b will be allocated over here. Okay, understood this one? And next time if I write a b equal to 20, what is going to happen? Okay, b is allocated with what? These two blocks, and whatever value I give, that 20 is going to be stored in this memory, in this particular memory. Again, you can see these two are again 2 bytes of data. Are you following, students, here?
Yes, sir.
Okay.
Sir.
Now, suppose if there is a data type char, say C. Now who can tell me what should happen? What will happen in the compiler? That what will happen in the computer memory? Who can answer? When I declare a char C, then what is going to happen? Fall on to the
Going to
basic.
show an error.
C is what? What type of data it is? Character. So character requires how many bytes of memory?
1 byte.
1 byte.
1 byte of memory. Then what compiler should do? It should identify a memory in the computer which can store 1 bytes, and it is very simple for computer now here, because each block can store 1 byte. So wherever it finds a free block, it can allocate this 1000 and address, or it can allocate 1003, or it can allocate 1008, or anywhere in the computer memory. It depends upon the compiler and the computer architecture how it allocates the memory. For example, let us consider that it is going to allocate over here. So I get a C here. So C will say that okay, C is going to be allocated for 1003, right? And C will get allocated over here. And suppose if I write C equals to within a single quote, say let me write a character Z, right? Character Z, if I initialize, then that particular Z is going to be stored over here. Z is going to be stored over here. Following it?
Yes, sir.
Okay. Now what may happen if
Yes,
you
sir.
declare a float variable? If you declare a float, say f is equals to 3.142. So what may happen here?
4 bytes.
4 bytes will be allocated. Are they 4 bytes? Are they in consequent memory locations? Are they consequent memory locations, or here and there any memory locations? Is it going to take 4 bytes, 3 from here and 1 from here? Will it do?
Yes, sir. Yes, sir.
Will it allocate 1004 one byte and then 3 bytes the next year? It cannot, because float requires a 4-byte memory and this should be a consequent memory blocks. So what it can do is that, okay, from probably from here to the next 4 bytes, it will allocate, that is 1007 to 1010. It will just allocate all these memory blocks. Isn't it? Following? At any time, if you find that you're not following, please do ask questions. Please do interrupt me if you're not following. Okay, and this is say f here. So f is allocated for these 4 memory blocks. Are you following, students? I will go with a very slow pace. If you want me to repeat, I will repeat, because this is the basics. If you want to understand pointers, linked list, everything, this is the basics. Okay. Any doubts, students, as of now?
No, sir.
No, sir.
No, right? Okay. Now, coming back to our concepts, right? Give me a moment. Okay. Coming back to the array concept. In the array concept, we said that the elements of an array always are stored in consecutive memory location. What actually we mean by here consecutive memory locations is that, consider an example now again. Okay, let's say from here, let me have certain blocks. Let me put up certain blocks here. Okay, so let me call it to be a 2001, 2002, and let's have few addresses for the blocks. Okay, now let's say that programmer is declaring a integer variable. Okay, how do we declare a array of integer type? Say the name of array is marks. How do I declare? Suppose if I want to have a 5 elements in the array, then how to declare? Int
Mark square bracket 5.
square bracket and the size, that is the 5. Very good. Say so int marks 5. How compiler will interpret this, or how it will understand? It says that, okay, marks is not a single or a primitive data, but it is an array of single dimension, because there is only one pair of square brackets. And how many elements I need to allocate? I need to allocate 5 elements. Now tell me, how many bytes of memory is required for this marks array? How much of memory is required for this particular marks array?
I,
5.
5.
Okay, I got an answer 5. Any other answers?
10.
10.
10. Okay, any other answers? Okay, now how do we understand, or how we can calculate the size here, the memory blocks or the space? It's pretty simple. Now it is an array. Yes. What is the data type? Integer. So we know that to store a single element of an integer data type, I require 2 bytes of memory. I require 2 bytes of memory, right? And in this array, how many elements are there? There are 5 elements. So total size is what? 5, that is number of elements, multiplied by the memory for a single element, that is 2 bytes. So 5 into 2, that is 10 bytes. So compiler will say that, okay boss, I have the programmer has declared an array of integer data type, and he needs 5 elements in that. So you are going to allocate 10 blocks of memory, that is 10 bytes of a memory. Now pay attention, since it is an array, computer will not allocate like a 2 bytes here, a 2 bytes here, a 2 bytes here, because it is an array. Array means it is a collection of homogeneous elements one after the other. So the memory for those elements should be declared or allocated one after the other only. So it says to the computer that compiler will tell to the computer, you find out 10 bytes of continuous memory blocks which are free, and if you find something, then do allocate it. So what it will do, it will say that, okay, this is marks, it is marks, okay, and all these particular marks will take these 10 blocks. It will take these particular 10 blocks and it will get allocated over there. Now inside this, we know marks, individual elements of the this array is what? Marks of 0 is the first one, right? So marks of 0 will get allocated between 2001 to 2002. Okay, then marks 1, that is marks of 1 will get allocated between 2003 and 2004. Now can you tell me in the same fashion, marks 3, where it will be allocated? What is the starting memory address of the marks 3? Marks 2, sorry, marks 2, 2005. So marks 2 will be 2005 up to 2006, 2 memory blocks, right? These two are together. What about marks 3?
2007 and 2008.
2007, that is the starting address, right? Very good. Then what about marks 4? It is going to be 2009. That is marks 4. So these 10 memory blocks, that is 10 bytes, is completely occupied by whom? Occupied by the marks. It's occupied by the marks, right? And in this fashion, it will allocate the memories. The consecutive memory blocks allocation means this is the concept. Understood, students?
Yes, sir.
Right? Okay. Fine. We'll proceed with the, okay, let me acknowledge from your side. Are there any confusions here? Any doubts? Or you want me to repeat once again any of these concepts? Let us go in a slow pace, no need to worry, students. Okay, if the basics are perfect, then understanding the further concepts will be very easy. And for pointers, the concept of these memory blocks and all is essential. Without that, if you have certain doubts here, you can't understand the pointers. Okay. Meanwhile, I think 2 minutes are remaining. Students can enter your attendance. Go ahead and enter your attendance. Okay, I think meanwhile you can, we know these concepts also, right? The elements of the arrays are accessed by a number called as an index. What is the first value of the index?
0.
0.
0. It is 0. And total number of elements which are stored in the array, we usually call it to be its size of the array.